Alright, we are going to start this next lesson. First, we are going to review things that we learned in the last lesson. So, let's look at the first question. It says, in the equation a equals 1, it will say plus or minus r raised to the t. A is the total amount, p is the principal amount, r is the annual interest rate, and t is the time in years. Which statement correctly relates information regarding the annual interest rate for each given equation? Alright, so here they're telling me for A equals P 1.025, the principal amount of money is increasing at a rate of 25%. Let me see if I agree with that. To get 1.025, they had to add 1 to it, so the opposite would be subtract 1 to it, which would give me 0.025. And if I want to get that back to a decimal, I'm going to have to times that by 100. So 0.025 times 100 would be 2.5%. Well, they're telling me 25%. I don't agree with 1. Let's look at 2. All right, let's see what 2 is saying. They're telling me 1.0052 is increasing at a rate of 52%. Well, let's do the same thing. 1.0052 subtract 1 is 0.0052 and times that by 100, we get 0.52%. Not going to work. So not that either. Let's try number 3. Number 3 is saying 0.86, the principal amount of money is decreasing at a rate of 14%. Well, to get 0.86, they had to do 1 minus whatever the percent rate is. So I'm going to do 1 minus 0.86 to see what's left over. 1 minus 0.86 is 0.14. And let's get that into a percent by timing it by 100. Hey, that works, 14%. Our answer is choice 3. Let's just make sure we don't like answer choice 4. Answer choice 4 is saying 0.68 is decreasing at a rate of 68. It can't be that because it's never going to be the same number unless it was 50%. So not that. All right, answer choice 3. Let's look at number 2 now. Number 2 is saying the equation A equals 1,300 parentheses 1.027 is being used to calculate the amount of money in a savings account. What does the 1.02 represent in the equation? Well, because it's over 1, it's definitely going to be growth. So I'm going to get rid of anything that means decay. And now, to get that 1.02, they added 1 to it. So they took 1 plus some number, and that's how they got 1.02. So the opposite for me would be to subtract 1, which would give me 0.02, but that's not a percent, that's a decimal. So now I need to times that by 100 to get a percent, and I'm going to get 2, so it would be a 2% growth, which is answer choice 4. Nice job. Alright, so now we're going to get into today's lesson, where today we are going to continue to write equations for exponential functions and evaluate them for certain values. Today we're going to focus on decay questions, where it's going down, where it's decreasing. So percent decrease. To turn the percentage into a decimal, we divide it by 100, and then we do 1 minus whatever the decimal is to find the percent decrease. So again, we can use this same exponential formula where we have f of x, or you could put y equals a, which is the initial amount, and then b is going to be the constant of decay. This is going to be a number smaller than 1 but bigger than 0 because we're decreasing, and then we raise it to the exponent of x, where x is usually the time. So let's look at this guided practice problem. It says, each year the local country club sponsors a tennis tournament. Players start with 128 participants, and during each round, half of the players were eliminated. Well, half would be 1/2, which to make that a decimal would be 0.5, and then we would have some amount of time, which here it's rounds. So we can say that the number of participants is whatever the initial was times half of it, and they want to know how many after 5 rounds. We're going to raise it to the 5th exponent. So 128 times 0.5 and put it to the 5th exponent is 4. Wow, 4. So after 5 rounds, 4 participants will remain. That's crazy. It started out with 128, and then think about it. Let's think about it. After one round, there was 64. Then after 2 rounds, there was 32. After 3 rounds, there would be 16. After 4 rounds, there would be 8. And after 5 rounds, there would be 4. So you could technically do that just by thinking about that logic. Alright, I want you guys to try this individual practice problem. Pause it, try it, think about it. Alright, it says, a ball is on the ground and it is decomposing. Decomposing means it's breaking apart, it's decreasing. The ball loses half of its weight each day. If the ball weighs, so it starts by weighing 80 grams, and it's losing half, you could even put it as a half, and after some amount of days. So, let's see. They want to know after 7 days, so I'm going to raise it to the 7 exponent. So I'll have 80 parentheses 1/2 raised to the 7th, which would be 0.625 grams after 7 days. And if you really didn't know how to set up this formula, you technically could divide by 2 7 times, 3, 4, 5, 6, 7, and you would get the same answer. As long as this is a multiple choice question, they don't ask you to write a equation, you technically could just do that. Alright, now let's get into the percent change formula. This is where you're going to have your final amount, y equals whatever your final amount is, equal to your initial amount, and then you need a rate of increase or decrease. This is where you are going to put your growth or your decay factor by doing 1 plus or minus whatever that rate of increase or decrease is. If it's given to you as a percent, you need to make it to a decimal. Even if the decimal is a percentage, if the percent is a decimal, you still need to change the percent to a decimal by dividing by 100. And then your exponent. Alright. So I do. A car was purchased for $25,000. Research shows that the car has an average yearly depreciation. If you're depreciating, the car's value is going down of 18.5%. Create a function that will determine the value. They want me to use v of t. Okay. First we put our initial. Our initial was 25,000. Then we're depreciating, which means we're going to do 1 minus. I have to turn this percent into a decimal by dividing by 100. And that will get me 0.185. After t years, so I'm going to put t as my exponent. And what is 1 minus 0.185? That is v of t equals 25,000. Then in parentheses, we'd have 0.815 raised to the t power. Alright, now let's look at the question. It says, determine to the nearest cent. Remember, cents is 2 numbers after the decimal point. How much the car will depreciate from year 3 to year 4. Okay, let's start at year 3. To do that, I'm just going to put this to the exponent of 3. So let's see. 25,000. 0.815 and raise it to the 3rd power is 13,533 and 0.58. Okay, 13533.58. Okay, now let's try this problem again with the 4 as the exponent. 0.815 with 4 as the exponent. Alright, we would have v of t equals 25,000, 0.815 raised to the 4th power would be 11,000.87. And if they want to know how much the car depreciates from year 3 to year 4, we will have to subtract these two numbers. So 13533.58 minus 11029.87. I'm just going to check that I typed this in the calculator correctly, because it's very easy to make a mistake. Alright, and we get 2,503. So from year 3 to 4, the car depreciates $2,503.71. Alright, now let's look at this we do problem. Let's look at this problem. Her mom takes a 400 milligram dose of aspirin. Each hour, the amount of aspirin in a person's systems decreases by 29%. Write an exponential decay function to represent this situation. All right, so I'm just going to put y equals the initial amount. The initial was 400. And then because we're decreasing, I'm going to do 1 minus. I need to turn this percent into a decimal. That would become 0.29. So 0.29. And I raise it to the time, which is hours. All right, now in this problem, they want to know how much would be left after 6 hours, which means I'm going to have to raise this to the 6th power. And what is 1 minus 0.29? It'll be 0.71. You don't have to do that, but I just like to. So let's type this in the calculator. 0.71 raised to the 6th power would be 5.1. They don't tell me what to round to, so I'm just going to round to nearest 2. So 5.1 milligrams left after 6 hours. Alright, now I want you guys to try this you-do problem. So, let's try this problem right now. It says, the yearly profit of a company is $25,000. The profits have been decreasing by 6% each year. And we have to write a situation for this. So y equals the initial amount, which is 25,000. And then parentheses 1 minus 6% as a decimal would be 0.06. And we'll raise it to whatever time. We could put x, we could put t, it doesn't really matter. Alright, so they want to know what will be the profits after 8 years. So let's try this. 1 minus 0.06 raised to the 8th power. So 25,000. 1 minus 0.06 raised to the 8th power would be, to the nearest dollar, would be 15,239. Profit in 8 years. Alrighty. Now let's look at a few regions problem. It says, the equation v of t equals this represents the value of a motorcycle t years after it was purchased. Which statement is true? Okay, this is the amount when purchased, 12,000 when purchased. It wasn't 9,000 when purchased, but it could be 12,000 when purchased. The next one says the motorcycle is decreasing at a rate of 75% each year. No, let's see what it's decreasing at. To get that 0.75, they did 1 minus some number to get 0.75. So we could do 1 minus 0.75 to see what that number was. 0.25. That is not a percent. We need to times that by 100 to find the percent, which would mean 25%. Which none of those say 25%, so our answer would be choice 2. Now let's look at this one. He has his money invested in a stock portfolio. The value v of x of his portfolio can be modeled with this equation, where x is the number of years since he made his investment. Which statement describes the rate of change? Alright, it's definitely decreasing since the number is smaller than 1. Let's see what it's decreasing by. So I'm going to subtract this from 1. 1 minus 0.78 equals 0.22. Again, that is not a percent, so we have to times this by 100, and we would get 22%. Which is choice 2. Just know it's never going to be the same number that you see. If it's 78 there, that's not how much was taken away from 1, so it's never going to be that. And that wraps up our lesson on exponential decay.